Welcome back to Aurora Tech Channel. Today, I'm going to test out the Sovol SV08 Max, a large-scale CoreXY 3D printer with a massive 500 by 500 by 500 millimeter build volume. Since CoreXY machines require less table space than bed slingers, the footprint for this printer is about 700 millimeters by 750 millimeters, with a vertical clearance of around 800 millimeters. As you can see, it fits comfortably on my 30-inch deep table. The printer uses a linear rail on the x-axis, dual linear rails on the y-axis, and 4 linear rails with 4 independent stepper motors on the z-axis. This setup allows the entire gantry to self-level. It features an eddy current sensor that scans the bed rather than probing it point by point. It can scan a 60 by 60 grid, or 3,600 points, in about 1.5 minutes. The Z offset is set by having the nozzle physically touch the bed using a strain gauge. The claimed top speed is 700 millimeters per second, with acceleration up to 40,000 millimeters per second squared. The maximum flow rate is 50 millimeters cubed per second, and the nozzle can reach temperatures up to 300 degrees Celsius. Cooling is handled by 2 part cooling fans inside the print head with no auxiliary fan. The extruder is a direct drive type with metal gears. Filament is fed through a long Bowden tube from the spool, and there's a powered filament feeder with its own stepper motor to help reduce friction. The heated bed is a 1,300 watt AC unit with a maximum temperature of 100 degrees Celsius. It comes with a double-sided black PEI coated sheet. An enclosure with a heated chamber is available as a $200 upgrade. By default, it includes a 4.3-inch color touchscreen with Sovol's custom UI. There's also an HDMI port available if you prefer to use a larger screen with the standard Klipper screen interface. The SV08 Max runs Klipper firmware on an MKS Pi motherboard and is powered by a quad-core 1.5 GHz CPU with 1 GB of RAM and 8 GB of eMMC storage. It supports USB drives, 2.4 GHz, and 5 GHz Wi-Fi, and Ethernet, so you can send prints directly from Orca Slicer. It also includes a 720p camera with Obico pre-installed, allowing you to monitor and control the printer remotely, even when you're not connected to your local network. The SV08 Max is now on Kickstarter with a super early bird price of $999. If you want the enclosure and heated chamber, the total is $1,198. According to the campaign, production is already underway, with estimated delivery in August. I would like to thank Sovol for sending us this machine and for sponsoring today's video. As always, even though this is a sponsored review, we won't hold back from pointing out any cons. With that said, let's get started. The box of the machine is large, but smaller than I expected considering the print volume, as the frame components are stored in separate layers and require assembly. This helps reduce dimensional weight by allowing a more compact box. After unpacking everything, you'll find the base, 4 Z-axes with independent stepper motors, several brackets to reinforce the frame, a touchscreen, a filament feeder, and some general tools. In addition, there's the gantry and the top frame. If you have experience assembling 3D printers, this should be pretty straightforward. We'll start with the base and Z-axes. Fortunately, the Z-axes are labeled Z1 to Z4, and the base corners are also labeled accordingly. Just match them to the correct corners. The screws are clearly labeled as well, though the step numbers can be a bit confusing since some screws are used in multiple steps. After attaching the 4 Z-axes to the base, install the top frame, followed by the stand for the extra long Bowden tube. Then insert the gantry into the frame, followed by the print head, which is secured to the X carriage using 3 screws. Next, install the screen on the front of the machine and attach the spool holder on the right side. The filament feeder is mounted above the spool holder on the same side. This setup helps push filament through the long Bowden tube to the extruder. Finally, connect all the cables. Once assembly is complete, plug in the power and turn on the machine. The screen UI starts with a setup wizard. First select your language, then connect the printer to your Wi-Fi network. The Wi-Fi module supports both 2.4 GHz and 5 GHz networks. After that, it begins a self-test, starting with homing and setting the Z offset, followed by gantry leveling and bed leveling. Interestingly, there's no probe. Instead, the machine uses an eddy current sensor to scan a 60 by 60 grid, totaling 3,600 points. If it used an inductive sensor or BL Touch, this process would take hours, but with the eddy current sensor, it finishes in about 1.5 minutes. Finally, it performs input shaper calibration. After that, the printer is ready to print. However, before starting the first print, I would also check for any available firmware updates. After updating, I loaded Filament using the touchscreen menu. Because the Bowden tube is so long, the filament feeder starts pushing the filament as soon as you press the button. It continues feeding until the filament reaches the sensor inside the print head. It then continues feeding automatically, similar to the Bamboo Lab AMS hub, but this feeder has its own stepper motor inside. I started with the preloaded 10-minute benchy G-code. The prep routine begins with homing, then wiping the nozzle on the silicone pad located on the left side of the print bed, followed by auto Z offset and gantry leveling. Bed leveling scans only the print area. The full prep time, including heating, took about 5 to 6 minutes. The preloaded G-code is extremely fast. I noticed some residue from the nozzle, but it was blown off by the part cooling fan after a while. After a few layers, I ran a sound test. From about 1 foot away, the noise level hovered in the mid to low 60s, jumping to the high 60s during rapid movements, and it pretty much stays the same throughout the entire print. The print completed in just over 10 minutes. While the speed is the fastest I've tested so far, the print quality was rough. I then sliced another benchy using the default slicer profile, aiming for an approximately 30-minute print for comparison. This second print took slightly over 30 minutes. The screen doesn't show seconds. The surface quality was noticeably better, though still with more stringing than ideal. Cooling at the front was sufficient for both prints, but the 30-minute version had cleaner layer lines. Looking at the top layers, the fast benchy had lines so wide they barely touched, whereas the slower one had more standard line width with slightly more stringing than usual. Since the filament profile in the slicer was tuned for Sovol branded filament, I used a brand new spool from Sovol to reprint both the fast and normal benchy. Here are the results. The fast version remained very rough, while the normal speed print had much better surface quality. However, both results were similar to prints I've done with VOXELPLA Pro. All 4 benchies showed more stringing than I would prefer. The front cooling is good, and the galaxy-colored filament helped hide some of the layer lines. From the top, you can again see that the line width on the fast benchy is too wide, making the lines barely touch each other, while the 30-minute version looked much better. This machine can print very fast, but I would sticking with the default print profile for a better balance between speed and quality. For the benchmark test prints on this machine, I'll be doing things a little differently than usual. Since this bed is huge, we can print all the models at once, but instead of printing them layer by layer, we'll print them object by object. As you can see, it finishes one object before moving on to the next. This method requires more clearance space between models to avoid collisions, and the printer will start with the shortest object and progress to the tallest. Now let's upload the file, which is over 60 megabytes. Thanks to 5 GHz Wi-Fi support, it's still pretty fast, about 17 seconds. The total time for all prints came out to 8 hours and 49 minutes, which is faster than average. The typical total print time for these 4 models is around 10 hours and 45 minutes. The top of the number slider looks good, and the bottom printed beautifully with proper clearance. On the honeycomb box, the small honeycomb patterns came out clean and intact, though there were some minor imperfections on the bottom, nothing too serious. Compared to other high-quality smaller printers, the SV08 Max isn't the best in print quality but still falls within an acceptable range. The Robo Alpaca looks decent, although the galaxy-like filament tends to hide layers and artifacts. For a more accurate comparison with the same model printed on other machines, I'll reprint it using the same PLA I used before. This single object print was also faster than the average 4.5 hours. The surface quality looks alright, so let's compare it to other printers from best to average. Compared to the Chitu Plus 4, which still holds the best surface quality among all tested printers, the Plus 4 clearly wins in quality, but the SV08 Max is about 18% faster. Compared to the Bambu Lab H2D, the second best in surface quality. The H2D still has better results, but the SV08 Max is about 15% faster. The Creality K2 Plus is 16% faster than the SV08 Max and also has better surface quality. The Prusa Core 1 also delivers better surface quality, but the SV08 Max is around 17% faster. Now looking at some larger printers, compared to the Mingda MD400D, which has a 400mm cube build volume, the SV08 Max prints faster and with similar surface quality. And compared to the largest printer I've ever tested, the Elegoo Orange Storm Giga, the SV08 Max is more than twice as fast and also delivers better surface quality. While the SV08 Max may not match the surface quality of top-tier or refined standard-size printers, it performs better than most machines in its class. Let's take a look at the final benchmark print, the tolerance test. On the square side, it barely clears the 0.075mm gap, which isn't great. More surprisingly, it fails to clear even the 0.125mm gap on the cylindrical side. This suggests that the default PLA profile in the slicer is slightly over-extruding. To fix that, I'll open Orca Slicer and run a flow calibration test to dial in the extrusion rate more precisely. I printed a set of calibration tags with extrusion values ranging from plus 20% to minus 20%, using Sovol filament and 2 of my regularly used filaments. As expected, the plus 5% to plus 20% tags are clearly over-extruded. Even the 0% tag, the current extrusion setting, is a bit over. The minus 5% tag looks okay, but might be slightly under-extruded. So, I'll settle on negative 2.5% as a middle ground. The default flow rate is 0.98, so I'll reduce it by 2.5% to 0.955. I'll save this as a new profile and reprint the tolerance test. The new print took 1 hour and 14 minutes, slightly faster than the typical 1.5 hours. This time, it successfully cleared the 0.05mm gap on both the square and cylindrical sides, but stopped at zero clearance, confirming that the extrusion is now much better calibrated. Since I'll be printing PACF and TPU later, I'm drying them first using the Chitu dual chamber dryer. I've set PACF to 70 degrees Celsius and TPU to 55 degrees Celsius. While drying, I ran a few other test prints. Starting with PETG, we're setting up a budget indoor golf simulator, so I will print a wall mount for golf clubs. The model is 553mm long, so I rotated it 45 degrees to fit the 500 by 500 bed. I used a nozzle temperature of 265 degrees Celsius and a bed temperature of 85 degrees Celsius, with added supports for the overhanging base. During printing, I noticed a bit of filament residue, but it didn't seem to affect the result. The print took 4 hours and 9 minutes. There was no warping, and PETG printed mostly cleanly. I do think the default 10% infill is a bit low for this kind of part, but overall it's still functional. Next, I printed a stackable ASA box. Since the test unit doesn't have an enclosure, I turned cooling off for the entire print. The bottom came out a bit rough, likely due to the low 10% infill and the lack of cooling, which caused an uneven transition between infill and top layers. This print took 3 hours and 32 minutes to complete. Aside from the rough bottom surface, there was no warping or layer cracking, even without using glue on the bed, and no enclosure, which is still not too bad for ASA. Before testing PACF and TPU, I decided to print something big, a 500mm tall Statue of Liberty. I let the slicer add tree supports, and the estimated print time was 23 hours 16 minutes. Sending this 155 megabyte file to the printer took about 57 seconds. The actual print took just under 25 hours, slightly longer than estimated. After about 5 minutes of removing the supports, the model looked awesome. It's so satisfying to print something at this scale. I placed a benchy and the Robo Alpaca next to it, just to show how massive this print really is. After over a day of drying, I moved on to TPU and PACF. Starting with TPU, I printed a golf tee holder for our simulator. The rubber tee is designed to hold a real tee with a height matching our hitting mat, about 2 inches. The default TPU profile is set to just 3 mm³ per second, which limits the top speed to 37.5 mm per second. I also increased the infill from 10% to 70% to make the tee unbreakable. As a result, the print took longer and finished in 62 minutes. There's some stringing in the center, but it still works well for its intended purpose. Next, I printed a cable holder using PA6CF. I imported the PACF profile from Bamboo Lab, and it worked fine on the SV08 Max. The print took 51 minutes to finish. When the nylon is properly dried, it prints just as easily as PLA. The surface looks clean, nothing to complain about for a simple functional part. Finally, I ran a first layer test on the massive 500 by 500 bed. The test layer was 495 by 495 millimeters and took 2 hours and 24 minutes. One side of the PLA sheet came out perfect, but the other side showed some line separation. While not flawless, this kind of first layer should still work fine for most prints. Let's talk about the pros and cons of this printer, starting with the pros. 1. The machine has a solid build with a rigid frame and substantial weight, which helps reduce vibrations and improve overall print quality. It also features cable chains that provide clean and organized cable management. 2. The quad gantry CoreXY setup is excellent. Not only can it level itself, but it's also not limited by the weight of the print, unlike bed slingers or CoreXY machines with moving beds. Since the bed remains stationary, you don't have to worry about the print being too heavy, even on a machine this large. 3. The print speed is impressive, not only faster than other large format printers, but also quicker than the average standard size printer. 4. The filament feeder is a great solution for guiding filament through the extra long Bowden tube to the direct extruder. It effectively prevents the feeding issues commonly seen on printers with extra long Bowden tubes. 5. The eddy current sensor used for bed leveling is extremely fast. It scans 3,600 points in just 1.5 minutes. It performs just as accurately as most inductive or BL Touch style sensors, but at a much faster speed. 6. It supports 5 GHz Wi-Fi and Ethernet for fast file transfers, which is especially useful on a large format printer. Since larger prints have more layers, the files are typically much bigger. 7. The AC heated bed heats up quickly. It reaches 60 degrees Celsius in about 4 minutes and 100 degrees Celsius in around 11.5 minutes, which is quite fast for a bed of this size. 8. It runs Klipper with Orca Slicer, Mainsail Web UI, and Obico for remote print monitoring, all of which are open source. This is a much better approach than other brands that use Klipper without disclosing it, pretending they develop their own firmware, Sovol has also published all the technical details of this machine on their GitHub as a fully open source project. Now for the cons. 1. The surface quality is decent and the print speed is fast. However, the accuracy test result right out of the box was below average, mainly because the flow rate wasn't well calibrated. After manually calibrating the flow ratio in OrcaSlicer, I was able to achieve results comparable to other printers, but I rarely need to do this with most machines I've tested. 2. The heated bed is a single piece with no individual heat zones, so it heats the entire surface regardless of the print size. Because of this, it's better suited as a second printer while using a smaller or standard size printer for everyday prints to save energy. 3. The 8GB eMMC isn't enough. After installing the Linux OS, Klipper firmware, and various plugins, less than 2GB of free space remains. While it's possible to store G-code files on an external USB drive, I'd prefer to see a 32GB eMMC on a large, modern Klipper-Based printer, especially since the cost difference is minimal. 4. The included spool holder only fits standard size spools. For a large format printer, it would be better to have an extendable or adjustable spool holder, similar to some community-designed options that can accommodate 2, 3, or even 5kg spools. 5. This machine is quite loud. During printing, the noise level jumps to the mid-60s decibel range, which isn't too bad considering my testing unit isn't enclosed. However, even when it's idle, the fan noise remains in the high 50s, which is louder than what I'd consider a reasonable level. In conclusion, the SV08 Max is a well-built machine that prints faster than any other large printer I've tested. It is even faster than many standard-sized machines while still maintaining decent print quality. While it may not be as refined or polished as higher-end models like the Bambu Lab H2D, X1C, or the Prusa Core 1, the SV08 Max has still performed the best among all of the large and extra-large printers I've tested over the past year. There are still some minor issues with the firmware, screen UI, and slicer profile. Those need to be addressed, but overall the machine worked quite well. This machine is currently on Kickstarter. Well, over the years, I've seen Kickstarter change a lot. I now see it as another online campaign platform that takes a 5% cut from each project. It's no longer just for startups. More and more projects on Kickstarter now allow buyers to pre-order products at a lower price from established companies. The trade-off is that you need to wait longer for the product to be manufactured and delivered. Still, definitely please do your own research if you're unfamiliar with how Kickstarter works. If you're interested in the SV08 Max, I included the Kickstarter link in the video description. Also, be sure to check out my website, auroratechchannel.com, where I track prices for major 3D printers, laser engravers, and CNC machines to help you find great deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.